Welcome to another solution with the physics tutor. This problem is from Giancoli 7th edition, chapter 11, problem number 4. The problem reads, estimate the stiffness of the spring in a child's pogo stick if the child has a mass of 32 kilograms and bounces once every 2 seconds. So again, we're in a situation where we're going to model our person, our child, as the mass attached to the end of a spring. The pogo stick is just going to be our spring. So you can imagine that what our system can be modeled as is a mass of 32 kilograms on a spring with a spring constant that is unknown. We don't know the spring constant. So that's what we're going to be solving for. So things that we know the mass is 32 kilograms. And we also have another piece of information. It tells us that the child bounces once every 2 seconds. The child has a mass of 32 kilograms and bounces once every 2 seconds. So that would mean, let's imagine if the child were starting here on the ground, and then they went up, and then they went back down. That would be one complete cycle of motion. So period of motion equals 2.0 seconds. So we can say period equals 2 seconds. The time to leave the ground and get to the highest position and come back to the ground would be the complete oscillation of our mass on our spring, essentially. So in this particular case, we are going to be solving for our unknown K value. What's the relationship that we know that puts mass and period and spring constant together? Well, for any mass on a spring, we have the relationship that the period equals 2 pi times the square root of the mass attached to the end of the spring divided by K. So we're going to be solving for K. So the first thing I'm going to do is divide both sides by 2 pi. And now I need to remove this radical so that I can isolate K. So to do that, I will square both sides of the equation, giving t squared over 2 squared is 4, and then squaring pi gives me pi squared, and that will be equal to the square of a square root, just gets rid of it, so that's m over k. Now again, I'm going to be trying to isolate k, so I'm going to multiply both sides of the equation by k, canceling it on the right and moving k to the left. So that will give me k t squared over 4 pi squared equals m. Now I want to isolate k. To do that, I will divide both sides by t, and I will multiply both sides by 4 pi squared, giving me k equals m 4 pi squared over t squared. And now I'm ready to input my numbers. So I would have 32 kilograms times 4 times pi squared, all divided by the period of 2 seconds squared. And at this point, you can plug that into your calculator. When you plug that into your calculator, you're going to come out with 315.8 Newton meters, which is going to round to 2 significant figures. So we have 2.0 seconds and we have 32 kilograms. So that'll give us an answer of 320 Newton meters for the spring constant, which is what we were solving for in this problem. If you found this video helpful, please like and subscribe to the channel. And as always, please enjoy physicsing.